Hello, everyone. I'm Johnson. Today, we will learn how to create flowcharts and swimlane diagrams using Axure. Additionally, I will introduce commonly used UML diagrams. A flowchart is like a map that shows the steps to follow to complete a task or solve a problem. It uses different shapes and arrows to guide us through the process. It's kind of like a game where you have to follow the right path to reach the end. Flowcharts help us understand how things work and make it easier to remember what to do next. There are lots of flowchart tools out there like Miro, Lucidchart, and Microsoft Visio online. But in my opinion, Axure is the coolest tool for making flowcharts. It's super easy to use and gives you the freedom to drag and drop different shapes and lines to create your own custom flowchart. When it comes to flowcharts, you don't need to worry about using all the fancy elements you might have seen in programming. The most important ones are the start and end points. Then you got action points between them. They're usually shown as rectangles. Then you've got decision points, which are like forks in the road and are represented by diamonds. A decision point can have multiple branches, and of course, you've got the lines that connect everything together. You can even add arrows to show the direction of the flow. Plus, you can make the lines look cool with different styles and colors. In Axure, there is a built-in library of flowchart components called Flow. The ones above listed are commonly used, while the ones below are less commonly used. You might wonder why Axure still includes the less commonly used components. Well, the history of flowchart components goes way back, and there is an international standard for them. You can refer to the following website for more information. On this webpage, you can see the meanings of various flowchart shapes. The ones listed above are the most commonly used shapes, while the ones below are less commonly used. In the database section, you can see magnetic disk. This refers to the early computer disks that were used, but they are rarely seen nowadays. The same goes for magnetic tape. Punched card refers to the old IBM punched cards. These are all shapes that were used in early flowcharts. It's good to have an understanding of these shapes, but they are not commonly used anymore. How can you create flowcharts that are easier for people to understand? By using the following flowchart structures, you can make your flowcharts more clear and comprehensive. Sequence. A sequence consists of processes that follow one after another. As you can see, it doesn't have any branches, making it very straightforward. This type of flowchart is also the simplest form of flowchart. Decision. This structure is called a decision or a conditional. It's like asking a question in the flowchart. Depending on the answer, the flowchart follows different paths. In the example, if the temperature is going to be below freezing 32 degrees Fahrenheit, the tomatoes should be covered. Loop. This structure lets you repeat a task multiple times. In the flowchart on the left, the task is done repeatedly until the condition is false. It always does the task at least once. In the flowchart on the right, the condition is checked first, and the task is done as long as the condition is true. In this case, the task may not be done at all. You can also reverse the conditions and still have a structured loop design. The chart shows a for loop. In this example, the task is repeated 10 times as x counts from 0 to 10. However, depending on the condition, the task may not be performed at all. There is also a for each structure, which is similar to the for loop but doesn't require a counter. It goes through each item in a collection and performs the task. You don't need to know the length of the collection or use a counter. It's like saying do this for every item in the collection. Case. The structure is called the case structure or selection structure. The decision structure is great when you have only two outputs, but if there are several, it can make the flowchart look crowded. That's where the case structure comes in handy. It helps make the flowchart easier to read and save space on the paper. Start and end. Every flowchart needs a starting point, but it can have multiple ending points. The starting and ending points are represented by the same shape, called a terminal shape. It looks like a rectangle with semicircles on the left and right sides. Connector block and off-page connector. If you need to divide a flowchart into different sections, you can use a connector block symbol, which looks like a circle. In the example, there is a circle with the letter A at the bottom left of the chart. This means that control should be transferred to another point on the chart that has a circle with the letter A. That point is located at the upper right corner of the chart. By using connectors, you can make the flowchart fit better on the paper. The circle can be used to refer to a point on the same page or on a different page. You can also use the off-page connector shape SH. The circle and the off-page connector are equivalent. Inside the circle you can use either letters or numbers. For off-page references you should use the page number, title, key, name, date. A good flowchart should have a title either on the chart itself or in the document's text. It's also helpful to include a key that explains the meaning of the shapes, especially if you're using any shapes that are not commonly used. Additionally, including the name of the author and the date of the last modification can be useful. The chart provides a basic overview of a retail store checkout process. The level of detail in a flowchart depends on its intended use. If you want to optimize each step in the process, you may need a more detailed chart. In some cases, it might be helpful to create separate charts for each step. The above is an introduction to basic flowcharts. In addition to basic flowcharts, UML can be seen as an upgrade to them. It is a graphical tool commonly used by programmers during coding. Since many programmers don't enjoy writing documentation, UML diagrams are generally used instead. UML is not very suitable for product management, but it is well suited for programming purposes. It has two main types, which are structure diagrams and behavioral diagrams. Now, let me briefly introduce these diagrams. Class diagrams are like blueprints for object-oriented solutions. They help us understand how different classes in a system relate to each other. In a class diagram, each class is represented by a box. The name of the class is written at the top of the box. Inside the box, we list the attributes characteristics of the class in the middle and the operations actions it can perform at the bottom. When there are many classes in a system, we group them together in a class diagram to make it easier to see how they interact. We use different types of arrows to show the relationships between classes. Here's an example of a class diagram. A component diagram is like a map that shows how different parts of a software system fit together. It's especially useful when dealing with big and complicated systems that have many parts. In a component diagram, we use boxes to represent the different components of the system. These components can be things like modules, libraries, or even individual pieces of code. They work together to make the software function. Components talk to each other by using interfaces, which are like special channels of communication. We show these interfaces as lines connecting the components. These lines are called connectors. Here's an example of a component diagram. A deployment diagram is like a picture that shows how your software is set up on different computers or devices. It helps us understand where the software is running and how it's connected to the hardware. In a deployment diagram, we use boxes to represent the computers or devices. Inside these boxes, we show the software that is installed on each machine. This could be things like apps, programs, or even websites. Deployment diagrams are especially helpful when your software is spread out across multiple machines, and each machine has its own special setup. It helps us see how everything is connected and working together. Here's an example of a deployment diagram. Object diagrams, also known as instance diagrams, are like snapshots of a system at a specific moment. They help us understand how objects relate to each other in real-world situations. Just like in class diagrams, object diagrams show the relationships between objects. However, instead of abstract classes, object diagrams use real-world examples to represent the objects. Object diagrams are useful when we want to explain complex relationships between objects using actual data. They give us a clear picture of how the objects interact and work together in a specific scenario. Think of object diagrams as freeze frames that capture a specific moment in the life of a system, showing us how the objects are connected and what data they hold. A package diagram is like a map that shows how different packages in a system depend on each other. It helps us understand the relationships between these packages. In a package diagram, we use boxes to represent the different packages in the system. These packages can be thought of as groups of related code or files. They help organize and structure the system. Use case diagrams are like visual maps that show us who is involved in a system, what they need to do, and how they interact with each other. In a use case diagram, we use stick figures to represent the people or things called actors who use the system. We also use ovals to represent the different tasks or functions that the actors need to perform. Use case diagrams are helpful when we start discussing a project because they help us see the big picture. We can quickly identify the main actors and the main processes of the system. This helps us understand what needs to be done and how everything fits together. Activity diagrams are like visual flowcharts that show how things work step by step. They help us understand the workflow of a business or a component in a system. In an activity diagram, we use different shapes and arrows to represent the different steps or activities in a process. These activities can be things like making a cup of tea or completing a task in a project. Activity diagrams are useful when we want to describe how things should be done in a clear and organized way. They can show the workflow of a business or the operational steps of a component in a system. State machine diagrams are like visual guides that show how objects behave based on their current state. They help us understand how objects change and act differently depending on their situation. In a state machine diagram, we use different shapes and arrows to represent the different states an object can be in. These states could be things like on or off for a light switch, or open or closed for a door. State machine diagrams are really helpful when we want to describe how objects behave in different situations. They show us the different states an object can be in and how it transitions from one state to another. Sequence diagrams in UML are like step-by-step stories that show how objects talk to each other and the order in which they do it. They help us understand how things happen in a specific situation. In a sequence diagram, we use vertical lines to represent the different objects or actors involved. Each object has its own line. We also use arrows to show the interactions between the objects and the order in which they happen. Sequence diagrams are important because they give us a clear picture of how objects communicate and work together in a specific scenario. They help us understand the flow of actions and the sequence in which things happen. Communication diagrams, previously known as collaboration diagrams in UML 1, are like visual conversations that show how objects talk to each other. They focus on the messages exchanged between objects. In a communication diagram, we use boxes to represent the objects or actors involved. We connect these boxes with lines to show the messages being passed between them. Communication diagrams are similar to sequence diagrams, but they have a different emphasis. While sequence diagrams show the order of actions, communication diagrams highlight the messages being exchanged. Interaction overview diagrams are like maps that show the order of different interaction diagrams. They are a way to organize and present a collection of interaction diagrams. In an interaction overview diagram, we use nodes to represent different types of interaction diagrams. These nodes can be things like sequence diagrams, communication diagrams, or other types of interaction diagrams. The interaction overview diagram helps us see the big picture and understand the flow of interactions between different diagrams. It shows us the order in which these interactions happen. Timing diagrams are like timelines that show how objects behave within a specific time frame. They help us understand the behavior of objects over time. In a timing diagram, we use horizontal lines to represent different objects. Each object has its own line. We also use vertical lines to represent time intervals. Timing diagrams are similar to sequence diagrams, but they focus on the timing and duration of interactions. If there is only one object involved, the diagram is simple and straightforward. However, if multiple objects are involved, a timing diagram is used to show how they interact with each other during that specific time frame. UML is not commonly used in product management, but it is frequently used by programmers for program design. Now let's discuss swimlane diagrams. A swimlane diagram is an upgraded version of a flowchart. It incorporates departments or roles, where each swim lane represents a department, facilitating logical analysis and collaboration across departments. In particular, for B2B products, there may be a need for collaboration among multiple departments or roles. By placing these departments or roles in swim lanes, we can gain a clear understanding of how they interact with each other. For example, in this image, you can see how the approval process interacts between the customer, sales, contracts, legal, and fulfillment. Swim lane diagrams are indeed widely used in practical product management work. In the next session, I will teach you how to create swim lane diagrams. Next, let me guide you through creating a flowchart and swim lane diagram using Axure. The product development process is a familiar process for many professionals in the internet and software industries. So today, let's create a flowchart for product development. Let's assume this is a B2B product development process. First, let's drag a rounded rectangle from the flow libraries in Axure to represent the start. As we mentioned earlier, rounded rectangles are commonly used to represent the start and end points. Next, drag a rectangle to depict a process. We start with user research, followed by requirement analysis, ideation, and prototyping. After creating the prototype, we need a decision for client approval. If the client approves, we move on to the PRD creation stage. If not, we go back to the prototype creation stage. Let's connect them with lines. On the right side of the diamond here, we connect prototyping with a connecting line to indicate that it hasn't received client approval yet. Then, drag in labels and enter no and yes. Place them next to the decision point. Continue drawing the flowchart. After PRD creation, we have UI/UX design, followed by coding, and then product launch. Finally, we reach the end. Let's connect them with lines. Here, we are missing one decision point. After completing the PRD creation, we also need a requirement review. Let's copy and paste a decision node. Label it as requirement review, and connect the lines accordingly. Duplicate yes and no labels. Great! Now we have completed a typical product development process. Isn't it simple? Axure allows you to flexibly and quickly create flowcharts. Next, let's create a swimlane diagram. The difference between a swimlane diagram and a flowchart is that swimlane diagrams have horizontal or vertical lanes that distribute the participants, such as departments or roles. By placing the participants on the lanes, we can better visualize their collaboration. This diagram will be more complex than a flowchart as we will include more processes. First, let's use rectangles to draw the titles and bodies of the swim lanes. Then, drag and drop a rounded rectangle into the client swim lane. This time, we'll be more detailed. Enter client needs identification to indicate the start. Since it belongs to the client participant, we place it in that swim lane. Next, let's create the user research process in the product manager's swim lane. Product managers need to conduct user research. Then, we move on to requirement analysis, followed by ideation. Next, we need to prototype. Drag a diamond shape into the client swim lane and enter client approval to represent the decision. If it is approved, proceed to PRD creation. If not, return to prototyping. Connect them with a connector line. Then, drag labels and place the text yes and no next to the branches. Here, let's duplicate a decision and enter requirement review. We'll place it here to represent a decision made by the product manager. Of course, if there are multiple roles involved, you can place decisions in multiple swim lanes. This time, it's just the decision of the product manager. Next is UI/UX design, which goes in the designer swim lane. Connect them with connector lines. After the design is completed, we have coding and product launch, which we place in the engineer's swim lane. Duplicate a rounded rectangle and place it in the client swim lane. Enter product acceptance to represent the end of the process. Connect all the processes with connector lines. The process part of the swim lane diagram is now complete. Next, we can add documents to the swim lane diagram. During the product development process, there will be many documents produced. After client needs identification, we have needs communication records. Drag a multi-documents element to represent it. After user research, we have a user research report. Use the document element to represent it. After prototyping, we have prototypes, represented by multi-documents. Then we have PRD and design assets. After the product is launched, there will be an operations manual. Change their styles to make them clearer. We can place them next to the processes. Finally, we can style the swimlane diagram. Adjust the colors to make it clearer and more visually appealing. Here, let's adjust the position of the documents to align them correspondingly. And there you have it, a swimlane diagram is complete. With a swimlane diagram, you can visualize the product development process, optimize the workflow, align with stakeholders, or identify any issues that may arise. If you like my video, please give me a like and subscribe to my channel.